So these are the questions. The first one is, what are the initial horizontal and vertical velocities? Okay. Right? And here they are. This is it. This is the answer to B. Okay? Is that they're 13.6 class 13.616 in the x direction plus, I'll just erase this, plus 20.967 meters per second in the y direction. I guess I need a meters per second there, right? So that's B, and we had that, right? What time is the rocket in the air? Well, that's the answer to C, right? Is that it's in the air for 4.28 seconds or something like that, right? How far does the rocket go before hitting the ground? I just multiplied this guy by this guy, and I got that it went 58.3 meters. Are we good so far? Did everybody get that? And then I'm going to skip E because E requires another calculation that I haven't done yet. Let's skip to F. Okay? F says, what is the speed of the rocket? Be quiet, please. At the highest point. Shh. Okay, at the highest point, remember, it's all x velocity and no y velocity. So what is its speed? If it only has its x velocity, what is its x velocity? No? 13.616. There we go. Meters per second, yeah? So there it is. That's its speed at the highest point. If you had to give its velocity at the highest point, you would say either one of two things. You'd say 13.616 meters per second in the x direction plus 0 meters per second in the y direction. Or you would say that it's 13.616 meters per second level, or 0 degrees, or something like that. Yes? Are we good so far? And then to find the height, we actually have for number, so that's F, right? To answer what E is, we actually have to set up another thing. I do another calculation. So we want to find X. This guy is 20.967. What is the velocity at the top? 0. This is negative 9.8. Right? And I would choose this formula. I would use this guy to find it. Okay? There's lots of ways to find it. Am I even on the camera here? I think I am. I'm very close. Okay? So I would use, for the highest point, I would use VF squared is VI squared. So 0 squared is right? And then it's always just the velocity squared divided by 2 divided by 9.8. .4 meters. So this distance here is 22.4 meters. That's the answer to E. Ta-da. Are we good? With the time we have left, let me set up the varsity questions for you. And the good news is for the varsity questions is that we can use this stuff here. The varsity questions are going to use the same launch velocity. This will be the same. This will be the same. And then they just give you something else, like time in one of them, displacement in another. Okay? So let's set those up so we can do those.